Greetings and welcome. My name is Mr. Waddy, and today we're going to do a lesson on solving quadratic equations by completing the square. And completing the square is a technique for rewriting a quadratic in one of our pattern forms, which are going to benefit us in some capacity in solving. And the pattern that we're going to be interested in today is the a plus b all squared equals a squared plus 2ab plus b squared pattern. And specifically, I'm going to be interested in solving problems like this. What if I'm solving the equation x squared, let's see, plus 4x minus 5 equals 0. And if I want to solve this, currently this side, this quadratic, is not equivalent to this pattern. Alright, in order for it to be this perfect square trinomial, well, first of all, I'd have to have my first term and last term be perfect squares, and it fails right off the bat. So it is not matching that pattern. However, there's potential for the first two terms to match this pattern. So what we're going to do is move this c term, alright, move our constant to the other side, and I will get x squared plus 4x blank, whatever new c term I'd need that would complete that pattern, equals 5. And I know that if I'm going to add some number or subtract some number here, I would also have to do it over here. So I put a blank on both sides, just in anticipation of adding some number right over here. I'd also have to add it over there, right? So what I'm going to do is figure out what number would make this a perfect square trinomial. And it's related to this pattern, because my goal is if I could get this to be a perfect square trinomial, I could then have it factored immediately into this square of a binomial, and I'd be able to just root both sides to kill that square and solve from there. So the question is, what number could I write here that would give me a perfect square trinomial? So one of the ways I can think about it, let's actually think of this pattern as I know I'm going to have my variable as my first term, right? Because a squared and x squared. A appears to be the x. And I'm looking for whatever my second term in the binomial would be. So let's just see if we can recognize what's going on here. If I was to expand this, this would be plus 2bx plus b squared. So looking at this and drawing some comparisons, I just want to point out that the coefficient of the x is 2 times b. And the term that will be my new constant, will be whatever that b is squared. So this term is going to be, notice this b value is going to be half of whatever my coefficient for the x term is. And my c term is going to be that value squared. So with that in mind, I'm going to say that my new c is equal to this term, alright, in this case my 4. I'm going to call that my b because that's what we're used to calling it. I'm going to take my coefficient for the b term, which is b, divide by 2 and square it. And this is how I'd find my new c term every time. Alright, based off of kind of some pattern recognition that we did there. So let's actually do that out. So my b term is 4, so my new c is 4 divided by 2 all squared. And let's simplify this. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 here, completing this square, this perfect square trinomial. That's where the name comes from. And I also would have to add 4 to the other side. So let's keep simplifying it. Sometimes, by the way, people will write this. This is just scratch work. You could write it over on the side. That would be fine. So let's keep going. So this is now a perfect square trinomial that factors according to that pattern. And I don't have to check to see if it matches the pattern. I made it match that pattern. And so when it factors, it's going to look something like this, right? Or in our case, it'll be x plus that b value squared. So ours is going to be x plus something squared. And that something, what I want to point out, is it's whatever I had before I squared it. So before I squared, I had a 2, so this should be a 2. X plus 2 all squared is in fact equal to this trinomial. Another way I could look at it is it's half of my b terms coefficient, or my x linear terms coefficient, maybe is the better way to say it. So it should have been half of this 4, and half of this 4 is also 2. And I do need to be aware of this sign as well, because it is possible that this could be x minus something sometimes. So whether I pulled this information from here or from half of this, I get that 2 one way or another. Okay? And let's write the right-hand side now. 5 plus 4 was 9. Actually, I'm going to leave some space here. So now I've just rewritten the way this originally was, right? Technically, this problem was factorable. I could have solved by factoring, and later we'll even see that I could solve by using the quadratic formula. However, this has this nice feature that this squaring is applying to this entire binomial. And notice my variable is represented only in that binomial. So what I'm going to do is actually square root both sides. And because this square is applying to the whole binomial and the square root is applying to the whole binomial, I will eventually be able to cancel this out. And when I square root both sides anytime while solving, I have to remember plus or minus for this side over here, the side that's furthest from my variable. So what I usually say is root both sides, and plus or minus, don't forget it, right? So kind of like land on your right foot, don't forget it. It's all about technique. And what we've got here is, oh, actually I'll even cancel it out with red here. So those cancel out. And I have x plus 2 equals plus or minus, what is the square root of 9? Well, that's 3. And now I could solve for x by, I'll subtract 2 from both sides. And I've got 2 possible cases. And remember that a lot of times our quadratics have 2 possible solutions, right? Sometimes they can just have 1, and it is even possible for them to have no real solution. But here I've got either x is negative 2 plus 3, or x is negative 2 minus 3. And if I simplify this, I'll get negative 2 plus 3 is 1. So there's one of my solutions, and negative 2 minus 3 is negative 5. So those are my 2 solutions. And I've now solved this quadratic successfully using a special pattern here. Now this might, it does appear as though we did a lot more work than if I had just factored this. But I want to point out that there's some strengths to solving by completing the square that factoring doesn't always have. And we'll look at it, actually, another example in just a moment, where if I didn't have this square root come out evenly, let's say this was the square root of 10 instead, this would have been plus or minus the square root of 10, and my answer would have been negative 2 plus or minus the square root of 10. And while solving by completing the square, I would have gotten an exact answer as a result. Whereas for factoring, if that was a 10, then the 5 would have been a 6, and this 6 here would have been a 6, or this would have been a 6, and x squared plus 4x minus 6 is actually not a factorable problem. So factoring doesn't always work. When it does work, a lot of times it's the fastest method. However, completing the square will always work. It's a guaranteed method for solving. So it's definitely going to be beneficial to know this for the times that, because I could spend a lot of time trying to factor a problem and then end up realizing in the end that, oh darn, it's not factorable, which would be terribly inconvenient for us. So let's try another problem. X squared minus 6x, let's say, we'll do minus, let's say, 4 equals 0. So once again, I have a quadratic, and I just want to point out, I could try to factor. I could say, are there any factors of 4 that subtract to be 6? And no, there are not. So this is not factorable. That doesn't mean that this problem doesn't have an answer to it, or answers even. So what I'm going to do is complete the square. And I'll actually lay out some steps for us in just a moment after I do this problem. But the first thing we're going to do is move this old c term to the other side, because that old c term doesn't give us a perfect square trinomial. And I do that and I leave 2 spaces, kind of foreshadowing that I'm going to be doing something to both sides. And what am I going to put there? Whatever will make this into a perfect square trinomial. And fortunately, we have a formula for that. Our new c term will equal b divided by 2 and squared, right? So b divided by 2 squared, in this case, is negative 6, taking care with that sign, divided by 2, and squaring it. So negative 6 divided by 2 is negative 3. Squared is positive 9. So I'm going to add 9 here and add 9 here. Right? If I do it to one side of the equation, I must do it to the other side in order to maintain the equality of that statement. And now conveniently, because I've created a perfect square trinomial, I know that this can factor very quickly, without much work, into the square of a binomial. And what that's going to be is, well, this was x squared, so this first term is x. And the second term is going to be what I had before I squared it, which is this negative 3. So x minus 3 all squared. So that I could have found it by taking it right from here, or I also want to point out I could have taken half of 6. And that's another way I could get, or half of the negative 6. So that's 2 ways you could recognize where that negative 3 comes from. And what's the right-hand side? 4 plus 9 is 13. So now to continue solving, notice conveniently I've got this whole thing squared. So to undo that square very quickly, I could root both sides, plus or minus, don't forget it. And the square root and the square cancel each other out. And I get x minus 3 equals plus or minus, and in this case, the square root of 13 is not a perfect square. But that's okay with us. I can just leave it as the square root of 13. If it could reduce partially, I should do that to reduce the radical. So like, for instance, if it was the square root of 12, I could break it down in the square root of 4 times the square root of 3. The square root of 4 reduces. But in this case, it doesn't. And so I can finish solving this problem. I'll just add 3 to both sides. And I'll get x equals 3 plus or minus the square root of 13. And I just want to point out that there are 2 answers represented here. I could get decimal approximations of them if I'd like. So 3 plus whatever the square root of 13 is, and then 3 minus whatever the square root of 13 is. And those would be the answers to this original problem. And it actually will work out. I could even do a check for it if I wanted to. So I just want to kind of lay out what the steps are. So solving a quadratic by completing the square, comp the square. These were our steps, and I'll refer to the previous example as I do it. So step 1, oftentimes when we're given a quadratic equation, we try to set it equal to 0 to factor. So whether it's set equal to 0 or not, you could do that as your first step. But I'm going to assume that it's already set equal to 0. But our first step we did was move old c to other side. And we see that that's what I did here. I had minus 4, I add 4 to both sides. So that was step 1. Step 2, what did we do? Step 2 was we found our new c term, right, and completed the square. So find new c, and new in quotes, which is equal to b divided by 2 and squaring it. and add to both sides. Was step 2. Step 3, I could then, once I had this written, I fast factored it, right, into the other form of the pattern. Okay, so fast factor, I call that sometimes. Right, so what I'm referring to is write it as x plus something all squared, right? And then step 4, once it was in that form, we were able to root both sides. So I'll even call this step root. Both sides. And plus or minus, don't forget it, right? And step 5, we would then solve normally using basic algebra. Usually at that step it's just adding or subtracting whatever number's left here. And that's a method that is actually going to solve any quadratic equation. And I realize sometimes it's more work. This is actually, for me, this is my favorite method of solving. I prefer this over any of the 4 methods of solving. And yeah, sometimes it is longer, but it is always going to work, and I kind of like the logic and the process of it. And I just want to point out, factoring, even though we might be fans of factoring, we might be really good at it, it doesn't always solve the problem for us, because we might not be able to. So anyways, so that's a basic look at solving by completing the square. A couple examples, one in which we had kind of a positive term there, and the second in which we had a negative there. And I just wanted to point out too that in our second example, the radical didn't reduce, but that was okay with us. That was okay with us. So I'll see you guys in the next video. I'll probably post another one on solving a couple examples of more complicated completing the square problems. So thanks, and look forward to talking to you guys soon.